Yeah. That's my best friend. Oh, she's you should, that is fine. Yeah, literally. Oh, I think that. I'm thinking more, but it was fun. Yeah. I don't like Okay, folks, we're going to continue talking about the covalent molecules. So on Friday, I introduced covalent molecules. Covalent molecules contain covalent bonds. Covalent bonds arise through the sharing of electrons between two atomic nuclei. Because covalent bonds arise through the sharing of electrons, the number of molecules that the same two elements can form is substantial. And on Friday, I gave you one example, and that was the alkanes. With the alkanes, we had nothing but carbon and hydrogen. And yet, I was able to give you 10 different molecules. And that barely scratches the surface of the alkanes. It's the simplest 10, that's all. Because of this fact that these molecules have, we need to be able to distinguish between them. And one way we can distinguish between these molecules is through their name. So on Friday, when I gave you methane, that was just CH4. Ethane was C2H6. Propane was C3H8. Basically, each of these combinations have a different name. Well, this process is going to continue. Carbon and hydrogen are not the only two elements that can combine in differing ratios. And it's extremely important as chemists that we're able to distinguish between how these elements combine. For example, one of these is best known as a greenhouse gas because it traps heat in, and that's carbon dioxide. The other one can kill you pretty quickly by replacing the oxygen in your blood, and that's carbon monoxide. I definitely want to be able to distinguish whether I am around carbon monoxide or carbon dioxide. I mean, both can kill me, but they do it in different ways. And understanding them is important to knowing what to do to not die. Another one, hydrogen and oxygen can combine in at least 2 different ways. One of these is essential to life. The other one is an aging agent. The one we want is water, which we've already learned to name. The one we don't want is hydrogen peroxide. So again, this issue really is arising due to the fact that these elements can combine in more than one ratio. We've got to be able to distinguish between them. We've got to be able to identify who we're working with. Now, we already have a way with the alkanes. And we're going to use some of what we learned with those alkanes with other molecules as well, in the fact that we are going to use a prefix system to distinguish how the elements have combined. So at this time, what I want to do is I want to go over the prefix system, and then we're going to get into these binary covalent molecules. If you have one of something, you use the prefix mono. Now, mono is only used on the second element. We don't need to use mono if there's only one of the first element. Again, you only use mono for the second element. We don't need to use it if there's only one of the first element. For all of the other prefixes, you're going to use it on the first element and the second element if need be. Wherever you need it, you use it. For 2, it is di. For 3, it is tri. For 4, it is tetra. And then if you'll recall, I said it's going to be a lot like it was for the alkanes. This is where it picks up, and it's just like it is for the alkanes. For 5, it's penta. 6, hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So these last ones starting with 5 down are the exact same prefixes we used for the alkanes. And as I mentioned, with di through deca, you will use as needed. For both the first and second element. So let me go back to my first 2 examples. The first element listed is carbon. So we say that it is carbon. The fact that there is only 1 carbon means that we do not need a prefix for the first element. But you will always need a prefix on the second element. In this first one, there is only 1 oxygen, so that's why we use the prefix mon, and it's monoxide. In the second one, there were 2 oxygens, so we say that there are 2 oxygens and call it dioxide. So the difference between the first 2 compounds that I gave you was the difference between us dealing with carbon monoxide and carbon dioxide. Let's look at N2O4. To name this compound, it's nitrogen. Yeah, damaged my pen. And it's oxide. But it's not sufficient just to call this nitrogen oxide. The reason it's not sufficient to call this nitrogen oxide is because another form is this one, where you have 1 nitrogen and 2 oxygens. Both of these, if I were simply calling it by its first element and its second element, would be nitrogen oxide. That's insufficient. You got to tell me how many of each there are. In this first example, there is 2 nitrogens, so it's dinitrogen. And it's 4 oxygens, so it's tetraoxide. On the second one, there is only 1 nitrogen, and then there are 2 oxygens, so it's dioxide. So let me just go over and let me clarify. I kind of got distracted by dropping my pen. covalent molecules. First of all, what do I look for to know it's covalent? If I'm just taking something off the periodic table, what does it have to be to tell me it's covalent? Non-metals and metalloids only. There better be no metals. Now, there are 4 types of covalent molecules. There is the diatomic elements. Does anybody remember the mnemonic device for the diatomic elements? Close. It's Brinkle. BR. Brink. Like brink. Brinkle pop. Those elements always have 2. They come in pairs. And you just name them by their element name. The next one was hydrogen with group 15, 16, and 17. How many hydrogens will go with a group 15 element? 3. How do we know it was 3? Because it's in group 15, and group 15 tends to carry a -3 charge, so you want 3 hydrogens to go with it. Group 16, it's going to be 2. And group 17, it's going to be 1 hydrogen. Now, because those can only combine in one way, for group 15, they can only combine in a 3-to-1 ratio. 3 hydrogens to 1 group 15. In group 16, because it can only combine in a 2-to-1 ratio, 2 hydrogens to 1 group 16. And in group 17, because it can only combine in a 1-to-1 ratio. To name them, we name hydrogen, we name the other element. Those were pretty well set in stone. We really didn't get into this idea of the same 2 elements being able to combine in multiple ways until we got to alkanes. And I'm having you learn the first 10 alkanes. But we took that idea that elements can combine in multiple ways, and we extended that to our binary covalent molecules. Again, just like alkanes, the same 2 elements can combine in more than 1 ratio. Because the same 2 elements can combine in more than 1 ratio, we use a prefix system to distinguish the ratio. The first 4 in the prefix system are different than the first 4 in the alkanes. But the last 6 are the same. And when we start naming compounds, we're literally stating what's going on. No prefix means 1. 1 carbon, 2 oxygen. You literally can read it. 1 carbon, 1 oxygen. It literally reads exactly how many there are. 2 nitrogen, 4 oxygen. It literally reads exactly how many there are. This is only going to be valid, though, for the binary covalent molecules. So now, to illustrate exactly what, well, not exactly because it's not the same molecules, but what you can expect on the test. Here we go. You will be given approximately 15 compounds that you have to name, and they will be all mixed up. This is what it's going to look like on the test. Well, except it'll all be in a column. That's supposed to be C2. This last one, this one is supposed to be C2. And we haven't named acid yet. That's Wednesday. And Friday.
Anytime the carbon and hydrogen are so they have a specific meaning. And it's not the same as what we did today. That was from the sheet. No, that's the middle. I went over it in fact. That's it. Not real, right? All the screening just got real with it. You're right. Yeah. Yeah, no, yeah, no, I So it's not Jack. It's just clone. I'm allergic to that. So 5%. So 5 is S2. Sulfur is S. Okay. What I could do is oh, okay, that makes sense now. You can't use the that's on binary. Because it's a when you're doing it, you're so so I was another so let's talk about how to approach this. You've been finding it and flipping back and forth between pages. So what are some things that you can do to approach this that may or may, I mean, I would say that it should help. The very first thing I do is I go through here and look at the first element listed. Put an M if it's a metal, put an N if it's a non-metal. That's the first thing I do. M if it's a metal, N if it's a non-metal. The reason
is if I put metal, it's ionic. If I put non-metal, it's covalent. So let me actually write these up here. So non-metal, this one was a metal. This one was a non-metal. This one was a metal. Okay. The reason I do that is if I put it as a metal, there's two types. Cation constant charge or cation various charge. Then I go in and on those cations, I go, okay, this one was a constant charge. This one was a varied charge. This one was a constant charge. This one was a varied charge. The reason I do that is because if it's varied, then you got to have a Roman numeral. If I said it was a non-metal, then I'm asking myself, is it diatomic? Meaning a diatomic element. Is it hydrogen with 15, 16, 17? Is it an alkane? Or is it binary, covalent? Because each one of those has a different way of naming it. So again, and you'll notice I used constant or varied for metal. Metal constant, just give the metal's name and the anion. Metal constant, just give the metal's name and the anion. Metal varied, give the name, the Roman numeral, and the anion. Metal varied, give the name, the Roman numeral, and the anion. Now, I'm going to erase some just so I have more space. Any questions about the metal one? Okay, this next one. You can come up with your own system. I mean, for the most part, diatomic, hydrogen, alkane, or binary.
This one is an alkane. That's why it ended in A and E. This one was an alkane. That's why it ended in A and E. I had to memorize both of those because they're not ones that you can use the prefix system with. This is a diatomic because di means two. Atom, literally, folks, this means two atom. In diatomics, you simply, whatever the element is the name. So that and chlorine were both diatomics. Because di means two, atomic, atom, two atom. Now I'm going to erase those four just to get them off the board. The rest of these, I didn't even give you a hydrogen with a group 15, 16. How would you have known if I'd given you a hydrogen with a group 15, 16, 17? Well, but the quickest way to know is I would have started with the hydrogen. So that's how you would have known it was going to be a hydrogen with a group 15, 16, 17, is I would have started with the hydrogen. So all of the rest of these are binary covalent, and that's why all the rest of them got the prefix system. Does that help you sort? Maybe a little bit? This is just a quick cheat sheet for the different types in as few words as possible. Now, half of them will be, give me the name, which I think is the hardest. The other half will be to give me the formula. So let's, in the last few minutes, I'll come up with some. And folks, I actually started the same way I started here because it kind of helps me adjust to which one I'm dealing with over here.
Yes.
I just had a real question. When it comes to the test, the formula that you gave us to find the charts and the category for the charts, is that going, that's something we need to memorize or would you go there?
Hadn't thought of that far in advance. I'll plan to give it to you.
You got enough to memorize with all of the polyatomic ions. And I'll probably next Tuesday, Monday or Wednesday, give you a shortened list that you have to know for the test.
Did that answer your question? Yes. Because they would simplify, because oxygen is a -2 and manganese is a +2. So when you do your cross drop, you have to simplify. Okay, any questions? On Wednesday, we're going to add 2 more names and formulas types to this list, which is the acids. And then we'll probably finish the week out practicing because this is the hard part of the test, in my experience. And so I think we will practice going before next Monday. And next Monday, we'll start getting back into the mathematics. I will see you on Wednesday.
Last week sometime I dropped off some donations for actual bonus when you wasn't in. Just making sure.
Yes, I got it.
I got everything out of the main office.
Okay.